Welcome to Math with Professor V. Here is your latest integral of the day. We have indefinite integral of cosine of the cube root of x dx. This one was also from the integration bee that I attended a few weeks ago where I teach. So anyways, if you want to pause the video on your own, give it a try. If you would like a hint, do a substitution first, and then you're going to need another integration technique. Okay, anytime I know I'm going to use multiple techniques of integration and I'm going to do a substitution, I usually save u for down the road just in case I have to do by parts or something. So in this case, I'm going to come in and let t be the cube root of x. Now you could just go for it and differentiate both sides. That way you could figure out what dx is in terms of t, but that's painful. Instead, let's cube both sides. Let's raise both sides to the third power. So then we're going to have t cubed equals x. And now differentiate. Oh, look how relaxing. 3t squared dt equals dx. Beautiful. Now we're going to rewrite this original integral all in terms of t. So now I have integral cosine. Instead of cube root of x, I'm going to replace that with t. And then this dx is all of this good stuff, 3t squared dt. How are we doing? Okay, good. Now, if you want to rewrite it, you can. And hopefully at this point you realize we're going to need to do integration by parts. All right. Now, we have a special case here because this is a polynomial. This is a trig function. And we're going to let u be the polynomial. dv would be the trig function because the derivatives of the polynomial will get simpler as we keep going, right? And these are just cyclical. It's going to take multiple rounds of integration by parts because 3t squared, I'll have to get it down to 6t and then just a constant in order to be able to integrate. And anytime I notice that it's going to take a few rounds, I like to use tabular, which works beautifully when this function here will eventually have a derivative of 0. Tabular also works on the ones that boomerang. And if you need like a little review or refresher on how to use tabular integration or the DI method, everyone has kind of a different name for it. I have a video, it's linked in the description. But this is just the perfect time and it makes it so easy. So you have one column that you differentiate, one column that you integrate, and it corresponds to how you would have picked u and how you would have picked dv. So I'm going to keep differentiating 3t squared, and I'm going to integrate cosine t. You start on the left. You keep differentiating until you get 0. So derivative of 3t squared, 6t, 6. And then finally, I've gotten a 0. So now I'm going to integrate cosine t 3 times, exactly. So antiderivative of cosine t, sine t. Antiderivative of sine t, negative cosine t. Be careful. And then one more time, negative sine t. Good? Now in the next step, you draw arrows on the diagonal starting on the left column, down one entry to the right. We're going to multiply all of these entries by each other. And the signs alternate from the product. So we have plus, then minus, then plus. If you've never seen this before, then in the video I explain what's going on. But the alternating signs has to do with the nested integration by parts that's going on here. Okay, so then finally, all we have to do is say, all right, this antiderivative is going to be this product here. So 3t squared sine t, and I don't need to change the sign because there's a plus there. 3t squared sine t. Then look here, this is 6t times negative cosine t times another negative. So that's going to make it positive 6t cosine t, and then the last product, negative, right? Because positive and negative 6 sine t. And then you just got to remember to put plus c there. So really, I could have done a u sub because I never actually used u or v for the by parts, but it's better to just be on the safe side. Okay, I know it's exciting, but it's not time to box the answer because remember we had made a substitution originally. Yes, t is equal to the cube root of x, which is also x to the 1/3. So I'm going to go back now, substitute in my original variable. So this is going to be 3 X to the 1/3 squared is going to be x to the 2/3. And then you have sine of x to the 1/3 plus 6x to the 1/3 cosine of x to the 1/3 minus 6 sine x to the 1/3 plus c. If you really wanted to go back to radical notation because that's how the original integral was written, feel free. When I wrote it out that way, it looked ugly to me. Do you want to see it? Yeah, I mean, or you could write 3 cube root of x squared sine cube root of x. It's already grossing me out. Plus 6 cube root of x cosine cube root of x minus 6 sine cube root of x plus c. I don't like it. You know what I mean? So anyways, that concludes the video. Hopefully you all were able to solve this successfully. And if not, then at least you learned something new that you can use moving forward in your math classes or just for personal enrichment. It's all beneficial regardless. Don't forget to give the video a thumbs up. Leave me a comment down below. Were you able to solve it? How did you like this one? And also if you need to review any of your integration techniques, topics from calculus, differential equations, linear algebra, then check out all the video lectures I have on my YouTube channel. They're organized into playlists. If you need advice on study habits, student life, I have a whole playlist on that, Ask Professor V. I also interview my students in several videos. And you can follow me on Instagram, TikTok, Twitter, Math with Professor V. I love you guys so much. Thank you so much for your support. And I'll be back sooner than later. Bye.